Stop. Look at the light coming from your screen right now. You've been told a rule your entire life. Your chemistry teacher told you. Your physics textbook swore it was true. It's the bedrock of reality. Energy cannot be created or destroyed. It can only change forms. Right? Wrong. That rule is a lie. Well, maybe not a lie, but it is a local rule. It works in your kitchen. It works in a steam engine. But when you zoom out to the scale of the universe, something terrifying happens. Every single second, the universe is stealing energy, vast amounts of it. Trillions of stars are pumping light into the void, and as that light travels to us, it arrives weaker than when it left. It didn't heat up gas on the way. It didn't hit dust. The energy just vanished, gone, deleted from existence. The universe isn't just expanding, it is actively killing the energy of the past. So where does it go? Does the universe have a hidden bank account? Or is physics broken? I'm going to show you the crime scene. And when you see why the universe hates light, you'll never look at the night sky the same way again. Let me show you. We need to talk about the first law of thermodynamics. You know the one. It's the golden rule of reality. Energy can neither be created nor destroyed. It's comforting, isn't it? It implies a cosmic fairness. It means the universe is a balanced checkbook. If you borrow energy here, you have to pay it back over there. But here's the part nobody tells you. That law comes with fine print. Imagine a box, a perfect, indestructible steel box. Nothing gets in, nothing gets out. Inside this box, you light a match. The match burns. The wood turns to ash. The chemical energy in the phosphorus turns into heat and light. Now, if you were God and you could count every single joule of energy in that box before you lit the match and compare it to after the match burned out, the number would be exactly the same. The form changed. The total amount didn't. If the air got hotter, the chemical energy went down. It's a zero-sum game. This is what we call conservation of energy. It works for steam engines, it works for battery packs, it works for black holes, mostly. But here is where your intuition fails. That rule, that beautiful, comforting rule, only works if the box stays the same. It relies on a hidden assumption that is so baked into our brains we don't even notice it. We assume the stage upon which physics happens is static. We assume that time is a flat, unchanging backdrop. But what happens if the box itself changes? What happens if the walls of the safe aren't made of steel, but are made of something that can stretch? See, the universe isn't a box. The universe is a dynamic, stretching, warping thing. And when the container changes, the rules of the content change. Think about it. If you have a gas trapped in a piston and you pull the piston up, the gas cools down. It loses energy. Where did the energy go? It went into the work of pushing the piston. Simple mechanics. But the universe doesn't have a piston wall to push against. There is no outside to the universe. So when light travels through the cosmos and the cosmos stretches, that light loses energy. But it doesn't push against a wall. It doesn't heat up an external room. It doesn't do work on anything. The energy just drops out of the math. This implies something that sounds impossible. It implies that for the last 13.8 billion years, the universe has been deleting energy on a scale you can't comprehend. But to understand how it commits this crime, we need to stop thinking about objects moving through space. We need to look at space itself, because space isn't empty, it's a killer. Let's talk about space. But first, forget the rubber sheet. You know the one, the bowling ball on the trampoline. Every pop science video uses it. Throw it out. That analogy is lazy. It tells you gravity pulls things down. But there is no down in space. Here's the real picture. Space isn't a stage. It's not a container. Space is a field. It's a dynamic, living fabric that dictates where here and there are. And right now, As you watch this video, that fabric is doing something strange. It's creating more of itself. Wait, think about that sentence. Creating more of itself. Most people imagine the Big Bang as an explosion, like a grenade going off in an empty room, sending shrapnel flying outward. Wrong. There was no room. There was no outside for the shrapnel to fly into. The Big Bang happened everywhere at once, and ever since then, the space between objects has been swelling. Imagine you are standing on a sidewalk, and suddenly the concrete beneath your feet starts to duplicate. For every meter of concrete, a new centimeter just pops into existence. You didn't move your feet, you didn't walk away, but the coffee shop down the street is now further away. This is metric expansion. This is the silent killer. Now you might say, okay, space gets bigger, so what? Things get further apart, who cares? Here's why you should care. Because light has to travel through this swelling mess. Light is a wave. It has peaks and troughs, up and down, wiggle and jiggle. The distance between two peaks is called the wavelength. Blue light wiggles fast. Short wavelength, high energy, angry. Red light wiggles slow. Long wavelength, low energy, lazy. Now watch what happens. As a photon travels through the universe, the space it occupies is stretching. It's like drawing a squiggle on a rubber band and then pulling the band. The squiggle gets longer. The wave gets longer. The blue light gets stretched into red light. The high energy becomes low energy. This is cosmological redshift. But here is the trick. Here is the part that breaks your brain. Energy is directly tied to frequency. E equals hf. If you stretch the wave, you lower the frequency. You lower the energy. A photon leaves a distant galaxy with 10 units of energy. By the time it reaches Earth, billions of years later, it only has 5 units. Where did the other 5 units go? Did they heat up the space? No. Did they push a piston? No. They didn't go anywhere. They simply ceased to exist. Every time space expands, it erases a fraction of the energy of every photon in the universe. So if energy is disappearing, is the universe broken, or is there a loophole? Let's hunt for the missing wallet. Let's follow the victim. Imagine a single photon, a tiny packet of pure energy. It's born in the chaotic heart of a supernova billions of years ago. It's blue, it's angry, it's screaming with energy. This little guy has one job: travel across the universe to hit your telescope. But the road isn't flat. As the photon travels, the road itself is getting longer. Every second it spends in flight, the universe adds more road beneath its feet. Wait. Think about what that feels like. Imagine you are running on a treadmill, but instead of just moving backwards, the rubber belt is physically stretching. The distance between your footsteps gets pulled apart. This is cosmological redshift. Most people think redshift is like the Doppler effect. You know, like when a siren drives past you, meow, the sound waves get squashed as it approaches and stretched as it leaves. But that's because the siren is moving. This is different. The galaxies aren't really moving through space away from us. Space is simply creating more space between them. The photon isn't just getting further away, it's getting tired. It's getting weaker. See, the energy of a photon is directly tied to its frequency. High frequency equals high energy. Blue, violet, gamma rays. Low frequency equals low energy. Red, infrared, radio waves. So when the universe stretches the wavelength, it lowers the frequency. It lowers the energy. By the time our little photon reaches Earth, it has been stretched so much it might not even be visible light anymore. It might be a microwave. It has lost 99.9% of its punch. Where did that energy go? In a normal world, if you stretch a spring, you put energy into it. You do work. Your muscles burn calories to pull the metal apart. The energy is stored in the tension of the spring. But here's the kicker. The universe doesn't have muscles. It doesn't have an external force pulling on the fabric of space-time. It just expands. There is no tension storing the lost energy of the photon. The energy didn't transform into potential energy. It didn't become heat. It didn't become mass. It just vanished. Poof! If you add up all the photons in the universe and you calculate their total energy today, it is less than it was yesterday. And tomorrow it will be even less. The universe is leaking energy like a sieve. This breaks everything you learned in high school. Conservation of energy is supposed to be sacred. It's supposed to be the one rule you can't break. So why is the universe allowed to break it? Is physics wrong? Or are we just looking at it the wrong way? The answer isn't in space. The answer is in time. And to find it, we need to meet a woman who was smarter than Einstein. Okay, let's stop and think about this for a second. This feels illegal. Physics is supposed to be about balance. It's about symmetry. It's about conservation. If you drop a ball, potential energy becomes kinetic energy. If you burn coal, chemical energy becomes heat. The total amount always stays the same. So if the universe is stealing energy from light, where is it going? Let's check the usual suspects. Suspect number one, the vacuum. Maybe the energy is getting sucked into empty space. Maybe the fabric of space-time is getting heavier as it stretches. Nope, that's dark energy. Dark energy pushes expansion. It makes space expand faster. It doesn't eat light. In fact, dark energy adds energy to the universe as it grows. Wait, that's another problem for another video. But it doesn't solve our missing photon problem. Suspect number two, gravity. Maybe the gravity of the galaxies is stealing it. Gravitational redshift happens when light climbs out of a gravity well. Like throwing a ball up, it slows down. It loses kinetic energy to gain potential energy. But here's the thing. The universe isn't a gravity well. It's flat, mostly. There is no up or down on the cosmic scale. The light isn't climbing out of a hole. It's just traveling. So gravity didn't take it. Suspect number three, the observer. Maybe it's just a perspective trick. If you run away from a siren, the sound pitch drops. The energy of the wave seems lower to you, but the sound wave itself hasn't changed. It's just your motion relative to it. Is cosmological redshift just a trick of perspective? Sort of, but not really. Because in the Doppler effect, the wave still has its original energy relative to the source. The energy is conserved in the frame of the air. But in an expanding universe, there is no single frame of reference. There is no still air for the light to travel through. The space itself is changing. The energy is genuinely gone from the perspective of anyone in the future universe. So we have a genuine paradox. We have a law that says energy cannot be destroyed. And we have an observation that says energy is being destroyed. One of them has to be wrong. The answer isn't in the physics of light. The answer is in the physics of symmetry. And this is where most people get stuck. They think conservation of energy is a fundamental law of nature, like a commandment from God. Thou shalt not destroy energy. But it's not a commandment. It's a consequence. It's a mathematical result of something much deeper. Something so simple you probably haven't thought about it since you were 5 years old. It's about time. Specifically, it's about whether today is the same as yesterday. And in an expanding universe, today is not the same as yesterday. The stage has changed. The rules have shifted. And when time changes, energy dies. Let me introduce you to the woman who proved it. Everyone knows Einstein. Nobody knows Emmy Noether. This is a crime, because she figured out the one thing Einstein missed. See, in 1915, Einstein was struggling with his own theory of general relativity. He realized that energy wasn't conserved in his curved space-time equations. It was disappearing. He panicked. He thought his theory was wrong. He called David Hilbert, the greatest mathematician alive. Hilbert couldn't solve it either. So they called Emmy Noether. She looked at the problem and said, "Hold my beer." Okay, she didn't say that, but she might as well have. She proved a theorem that changed physics forever. Noether's theorem. Here is the gist. Every conservation law in the universe comes from a symmetry. What does that mean? It means if you can change something about an experiment and the result stays the same, something is conserved. Space translation symmetry. If I do an experiment here, and then I move it 3 feet to the left and do it again, the result is the same. The laws of physics don't care where you are. Because space is uniform, momentum is conserved. Rotational symmetry. If I do an experiment facing north and then turn around and face east, the result is the same. The laws of physics don't care which way you face. Because direction doesn't matter, angular momentum is conserved. Time translation symmetry. If I do an experiment today and then I do the exact same experiment tomorrow, the result should be the same. The laws of physics don't care when you are. Because time is uniform, energy is conserved. Boom! Did you catch that? Energy is only conserved if the laws of physics are the same at all times. But wait, we just established that the universe is expanding. Today, the universe is bigger than it was yesterday. The density of matter is lower. The curvature of space is flatter. The temperature of the background radiation is colder. The stage has changed. Time is not symmetric in our universe. Today is fundamentally different from yesterday. The conditions for the experiment have changed. Because the universe is evolving, time translation symmetry is broken. And because time symmetry is broken, energy is not conserved. It's not a mistake. It's not a loophole. It's a feature. The universe is allowed to destroy energy because it is constantly changing its own rules. It is rewriting the fabric of reality every single second. And when you rewrite the rules, you don't have to keep the score. So, the energy of that photon? It didn't go anywhere. It just ceased to be relevant. The universe moved on and left the energy behind in a past that no longer exists. But this has a dark consequence. If energy is constantly disappearing, what happens when we run out? Because if the universe hates light, eventually it's going to win. So we've broken the first law of thermodynamics. We've proven that the universe is actively destroying the energy of light. But what does this mean for us? What does it mean for the future? It means the universe is slowly, inevitably, turning off the lights. Think about it. Every star in the sky is a fusion reactor. It's burning fuel. It's pumping out photons. It's trying to warm up the cold, dark universe. But the universe is fighting back. As the universe expands, it dilutes the energy density. It spreads the photons out over a larger and larger volume. And as it spreads them out, it stretches them. It steals their energy. It's a double whammy. Not only are there fewer photons per cubic meter of space, but each photon is weaker than the last. It's like trying to heat a house with a single candle while the walls of the house are expanding to the size of a city. The candle can burn as bright as it wants. It doesn't matter. The cold always wins. This is the heat death. Eventually, every star will burn out. Every galaxy will drift apart. Every black hole will evaporate. And the only thing left will be a sea of incredibly weak, incredibly stretched photons, radio waves, maybe even longer, waves so long they span the entire observable universe. The energy density will drop to zero. The temperature will drop to absolute zero. Entropy will be maximized. Remember entropy? That's the measure of disorder. It's the measure of how useless energy becomes. When you burn a log, you turn useful chemical energy into useless heat. Entropy goes up. But here's the twist. Because the universe is destroying the energy of light, it is actually accelerating the march towards maximum entropy. It is making the universe colder, faster. It is making the universe darker, faster. It is actively working to erase any structure, any complexity, any life that tries to cling to existence. The universe doesn't just hate light, it hates interesting things. It wants to be boring. It wants to be empty. It wants to be cold. And by stretching light, by stealing its energy, by breaking the symmetry of time, It is achieving its goal. But wait, is that really the end? Is the universe just a giant machine designed to destroy itself? Or is there something beautiful in the destruction? Because if you look closely at the lost energy, you might see something else entirely, something that hints at a beginning, not just an end. So we have a verdict. The universe is guilty. It is stealing energy. It is breaking the law of conservation. It is actively killing light. But here is the final twist, the one that should keep you awake tonight. It's not just about losing energy. It's about information. Every photon carries a story. It tells us about the star that made it, the gas cloud it passed through, the galaxy it escaped from. When the universe stretches that photon, it dims the signal. It makes the story harder to hear. Eventually, the signal will be so weak, so stretched, that no detector, no matter how advanced, will be able to pick it up. In the distant future, trillions of years from now, any civilizations that arise will look up at the night sky and see nothing. The light from other galaxies will be stretched into invisibility. The evidence of the Big Bang will be gone. The history of the cosmos will be erased. They will think they are alone in a static, eternal, empty universe. They will never know about the billions of galaxies that once shone. They will never know about us. They will be trapped in a cosmic dark age, ignorant of the vibrant, energetic past we live in right now. We are living in the golden age of the universe. We are the lucky ones. We get to see the light before the universe steals it. We get to read the book before the pages go blank. So tonight, go outside, look up, catch a few photons with your eyes, because the universe is trying to take them away. Don't let it. Witness them while you can. Like and subscribe for more cosmic crimes.